Alright. So I'll be showing the solution to problem number 12 in chapter 2. So the problem reads, the figure accompanying this problem shows the velocity of a solar-powered car as a function of time. Now the graph provided looks a little something like this. This is what the velocity graph looks like. X-axis is time in seconds, y-axis is velocity in kilometers per hour. Alright, so the driver accelerates from the stop sign, cruises for 20 seconds at a constant speed of 60 kilometers per hour, and then brakes to come to a stop 40 seconds after leaving the stop sign. Now there's two parts to this. So first we have part A. In part A, let's compute the average acceleration during these time intervals. So the first interval that's given to us is 0 to 10 seconds. So from here, and to compute the average acceleration, equation for average acceleration is v final velocity minus initial velocity all over the difference in time. So in other words, we're just finding like the slope, the average slope from here to here, because the slope of velocity is acceleration. So then that means for A, we just plug in our values. So it's 0 to 10 seconds. Oh. Yes, okay. Actually, let's just change this to t final minus t initial, because it'll make it a bit easier to follow. Okay. So first we just plug in our values. So 0 to 10 seconds. So 0 to 10 seconds, our final velocity is 60. Minus our initial velocity, which is 0, all over our initial time, which is our final time, which is 10, minus the initial time, which is 0. So then the average acceleration comes out to be 6 kilometers per hour squared. Okay? All right, now the next time interval that we have to find the average acceleration for is compute the average acceleration during 30 to 40 seconds. So then that's right here. So again, we just have our final minus initial. So we have our final velocity, which is 0, minus our initial, which is 60. Then we have our final time, which is 40, minus our initial time, which is 30. And that comes out to be negative 6 kilometers per hour squared. And that's our average acceleration for that time interval. Okay. And then the final interval it wants us to, or the third interval it wants us to look at is the average acceleration from 10 to 30 seconds. Now we can solve this pretty easily because acceleration is the slope of velocity, and clearly right here the slope is just 0. So right here the acceleration is just 0 kilometers per hour squared. Now the fourth time interval it wants us to find is, what is the average acceleration from the time interval from 0 to 40 seconds, so the full interval. And again, you can kind of just like look at this and just like kind of answer without even calculating. Because again, like the average acceleration is the average slope, and the average slope from here to here is just 0. And to check our math for that, it's just, again, just final velocity minus initial velocity all over 40, and that just comes out to be 0. So again, average acceleration is 0 kilometers per hour squared. All right. Now the second part right here, which is B, it asks, what is the instantaneous acceleration at t when t equals 20 seconds and at t equals 35 seconds? So an instantaneous acceleration is just what is that exact slope at that point that's given. So the first one that's given is what is the instantaneous acceleration at t equals 20 seconds? And 20 seconds is somewhere in here, so we immediately know the average acceleration at 20 seconds is just 0. And now for the next time, he wants us to know what is the instantaneous acceleration at 35 seconds. And again, so 35 seconds is just right here. And since this one is a linear line, it's a completely straight line,